All right, hello everyone, May the 12th. All right, let's get this done. Solving problems, questions. With brain power, you are given a zero-indexed 2D integer array questions where questions I, points and brain power. The array describes the questions of an exam where you have to process the questions in order, starting from question 0 and make a decision whether to solve or skip each question. Solving questions I will earn you points, but you will be unable to solve each of the next brain power questions. Wait, hold on. Each question has brain power, right? Points and brain power. Solving question I will earn you points, but you will be unable to solve each of the next brain power questions. If you skip question I, you'll get to make the decision. You get to make a decision on the next question. For example, given these questions, if question 0 is solved, you'll earn 3 points, but you will be unable to solve questions 1 and 2. Huh? Why? Hold on, let me read it again. Solving question I will earn you points, but you will be unable to solve each of the next brain power question. Each of the next brain power question. What does that mean? Each of the next brain power question. If I solve 0, I will not be able to solve each of the next 2 questions. That's what it means. So if you solve 0 and the brain power is 2, so you're not able to solve the next 2 questions. If instead question 0 is skipped and you solve question 1, you earn 4 points and you cannot solve then each of the next 3 questions, which is just, you cannot solve any one. Return the maximum. That's very interesting. Very, very interesting. Okay. Examples. Oh yeah, examples is you solve the 0 and solve 3. Well, DP, right? This is almost as clear a signal for DP as possible. We just need to figure out how we handle the DP, okay? So I guess it's going to be O(n) squared DP. So 2,000 to 1,000. No, it's 10 to the 5th, so it has to be O(n). Oh, at worst, O(n) log n. All right, interesting. Okay, let's see. So we have 3, 2, 4, 3, 4, 4, and 2, 5, right? That's what we start with. And we want to know the maximum to the end. Okay, so how about we say DPI is the max score, right? Max score solving problems, solving questions all the way to I. How about that? If we do that, we know DP, that's DP, right? So we DP have 1, 2, 3. So DP this, with the first one, definitely we just do 3, right? Now for this one, maybe it will be easier to do the other way because you need to skip, right? You know what? Scratch that. Scratch that. I don't like this. Let's do a top down. I think top down is easier to handle because you have to skip. Okay, let's say we have a DP index. Okay, that means the max score of solving problems, questions, right? Solving questions from I towards the end. Okay, that's what DP index means. Okay, so DP index. Well, definitely we can say we can solve the current one, right? So option one is we solve the current one, which is questions index, we solve this, and we get this. And we have to skip the next two, so we have the plus dp index plus 2, right? One. Actually, no, if it's 0, 1 to have the plus, not plus 2. Lord, it's not plus 2. It's plus questions index 1 and plus 1. That's option 1. And option 2 is we skip this question. Then that just equal to dp index plus 1, right? And then we'll return the maximum of option 1 and option 2. What's the edge case? Well, edge case will be if index is larger or equal to n, which is the length, then we'll return 0. Okay, let's give this a shot. Okay, we need it from func tools. Where are you cache? Right, I'm gonna cache it. Alright, def dp I index return int if n equals 1 questions, right? If index is larger equal to n, return 0. Otherwise, option 1 is equal to questions index 0 plus dp index plus questions index 1 plus 1. Option 2 is dp index plus 1, and I'll return the maximum of option 1 and option 2. And we'll do return directly dp 0. Okay, let's give this a shot. Does it work? I think it works. Edge case, edge case. I think edge case works. Oh, I've done this before. Oh no, I forgot the cache. Damn it. Sorry. It's too I went too fast. I did cache here. I forgot to include it there. Yeah, it was my fault. So improved, huh? Yeah, it's much more straightforward for me this time. It's like immediately sees that this problem is a DP. I smelled it. Okay, I smelled it. Let's see. Which sentence did you smell it? This sentence. If you skip, right? To solve or skip, that's the smelling. You know, you smell it. You solve or you skip. That's DP. And also because of this, it's easier to do it top down. Honestly, I don't even want to know how to solve it bottom up. I mean, definitely you can. Every top down can be translated to bottom up, but I don't want to, because top down is so much easier, right? You just in your head you have two options. You either do it or you don't do it, and then just go directly for it. The sentence solve or skip each question is a strong signal that this problem shall be solved. using DP. And we turn out to be ON, right? Oh, let's see, well, how did I do last time? Oh, look, here's the bottom up. Darn. I mean, yes, but you have to go from right to left. That's true, because you need to know if it's skip or not. Yes. If you do skip or not, you have to go from right to left, because at each question you have to decide whether you solve it or skip it. If you skip it, you have to go to the next one, and the next one better be solved already. So you have to go from right to left. That's why I don't want to do a right to left. It's always easier to go from top down. Brain power. Oh, now I know what brain power means. Brain power, right? You solve one problem, you exhaust your brain, you have to rest for 2 times. You have to rest for the next 2 questions. Stuff like that, right? Yeah, right to left. Yeah, recursion is so much easier. All right, so I guess we are good here, right? Yeah, I think we're good. Yeah, we have some time. It's kind of late, so I don't know. You at least have to debug it. We tried this yesterday and it didn't work. Okay. Look at this. This is just absolutely bonkers. I think we have a... Wait, hold a second. I need to comment out the... We didn't do these. We didn't do this. All right, anyway, so what the hell happened? Wait, why is this negative? Why it shouldn't be negative? You get the task, it should be positive. And then when you jump out, when you push it in, it should be negative. All right, let's try it again. Yeah, that was the problem. How about this one? Oh, this one fails. Okay, okie dokie. Okay, let's see. What did we start with? What are we talking about? We want, dear Lord, we want a heap, right? And want a task. Want to know what do we have? Oh my goodness, dude. Oof. It doesn't seem right. It doesn't seem right at all. Answer is 4. Result is 3. I got 3. No way. Something is not right. Okay? Something is not right. That's 2. Hold on. So what's this thing? I need to draw it. We have what? 1, 2, 3, 4, 5, and 6, right? 1 to 3, that's a 0. 2 to 5, 1. 5 to 6. Okay, that's 2. So what we need, we have in this position. So what's gonna be? Did I have to move this one here? All right, so the first one, man, I need to do it this way. Otherwise I cannot see. Okay, so we have 0, 1 at this position, right? 0 and 1 at 2. What's the first one? I don't even remember how I do. It has a number of overlaps. I have 2 overlaps, right? 0, 1 That's true. We have 0 and 1 overlapping here. And minimum length, 2 seconds, right? Because task 0 is 2 seconds. That's correct. That's that. And we have 0 by itself, starting at 1. And we have 0, 1 again, starting at 3. Yeah, that's true. But that's only 1. Correct. 5. No, 1. 1 start at 5. Ooh, that's not right. Because at position 5, dear me, at position 5, it's complicated. That's not right. At position 5, I have both at position 5. So at position 5, that should be a overlap, right? We have an overlap at position 5. But it does not show there's an overlap at position 5. Like at position 5, it's just 1. That's not right. Alright, that's not right. Hold on. Let's also see starts and ends. Starts. Position 1 starts at 0. Position 2 starts at 1. Position 5 starts at 2. Ends. Position 3 is 0. 5 is 1, 6 is 2. That's correct, right? So we go through this. Actually, I don't need to go through 2001 because I can just go through the maximum. Yeah, I can just go through the max of I just did 2001, that's fine. So I say t in ends, right? If it's in end, so this is in end. Oh. It shall be if it's Okay, I think we need to change this. I think what we shall do is, but anyway, why would this one doesn't work? I mean, it's if I don't do these at the same time. So 0, 1, I did 2, okay? So 0 is done, right? 0 is done. 1 has 1. Wait, why is 2 gone as well? What is 2 gone? I only did 0 and 1. It's a lot of issues here. Okay, I will get the task. So we have tasks, we have the time. Okay, so we go each task. If the task is in task duration, then we get a new task. Okay, and then in the beginning, new task is equal to. So I get a D is the minimum, is the new tasks. That's fine. Tasks and new tasks are the same thing. And get the current start T. So the D shall be 2, right? Remaining task. And I say for task in this, right? For task shall be for task in the keys. Oh, that is not right. This is not right. It shouldn't be in keys. Yeah, this is not right. It shall be, dude, this is not right. For task in tasks. So these are the tasks we're doing, okay? These are the tasks we're doing. These are the tasks we're doing. Yeah, you know what? Like this, a new task. Just let's call them new tasks. These are tasks we're doing, right? And then for task in task, and we have checked they are all in task durations. And we'll say this is minus equal to this. If not, delete. Else, we do this. If this, then we push. Now, if we do this, yes, this is right. Okay, we should have more. And the reason we have more is because we did something wrong here. And what we need to do is, whenever a time comes out, if the time's in, I see what you're trying to do. So no matter, it doesn't really matter. I shall say overlap equals overlap dot union starts dot get t. Okay, or set, and this whole thing dot union and dot get t set, right? Once we do that, we'll push it. Okay, we'll push this into actually, not really, because if the time point doesn't really exist, you just how about this? If t not in ends and t not in starts, continue. I really want to now go through all 2000, but it's a fine, right? Otherwise, it must exist in one of them. So we do that, right? We do that. And once we do that, we will definitely push the whole thing in, right? And after we push the whole thing in, then we say if t is in ends, then we need to get rid of it. So we do something like this. And then when we do this, now we pass, okay? Now we pass. This is very important. This is very important. We pass both. We pass both. Come on. What do you think? My timeout. That's what I think. My timeout. But oh boy, aren't I excited for this massive, ridiculous stuff. I don't even know the runtime, but let's try. Give it a shot. Very slow. Very, very slow. Oh. Okay. This is very wrong. All right, I think I'm gonna give up on this because I don't want to waste more time on this. Let's take a look at the hints. Binary search. Greedy. Sorting. Stack. Man, which one? Binary search. Well, I am doing greedy, but apparently this is not right, and we're hitting. You know what? Maybe we should. Yeah, you know what? Let's try this. Because because we got a timeout, so maybe there's still. How many did we get? Holy crap! I have 10,000 test cases. Jesus. Wait, like, do we solve this, or this one just time out already? Oh, this one time out already. Why? Okay, we have 2 to 8. Yeah, okay. And 4 to, lordy, 20. And 8 to 20. Okay, so what do we have? Let's put this test case in and take a look. I don't even know what the result is. I'll call it 0, but it's wrong, I know. And I know this is gonna time out, so I'm not doing this. I'm commenting out the whole thing. I just want to see if the if the heap looks right and the task duration looks right. All right, the heap. This is the heap we have. Let's see. The heap, we say 0, 1, 2 overlapping on here. Right, this point. 0, 1, 2 overlapping on 8. We can execute for 1, and then starting at position 8. That's correct. Next is 1 and 2. So 1 and 2 is 1 and 2 at 20. 0, 1 at 4. We have 2 to go because 0 has 2. Okay, and 0 at here. All right. So first I'm gonna do 0, 1, 2, right? So 0, 1, 2 we start from 8. And that is going to cause our, because it's gonna go only 1 second, because 0 only has 1 second. So 0 has 1 left. 1 has 6 left. 2 has 1 left, and we shall push back in. Actually, we shall push back in what? Well, there will be 9, right? The starting position should be 9. And oh, did we not check? I think we did not check that. Something is out of range. Task 0 is out of range. All right, so if it's not equal to, I'll redo it. That's fine. If it's equal to here, right? And rest plus D, remaining task. I have remaining task. Nah. This remaining task is it's wrong. So this is right. This is right. This, okay? We should not put a task unless we have more. So we know that the time, right? Ooh. So we do D. Remaining task. New time, new T shall equal to T plus D. Okay? So this is all new T. Okay? This is new T. New T. Right? And we shall say if elif, okay, new task, new time is smaller or equal to the tasks, right? Task 1. That's the range. right? The range. So for task 0, I cannot go to 9, right? I cannot go to 9 because it's outside the range. So if it's smaller or equal to, we add it. If it's not, we don't add it. Then we do this. Actually, all of these. Let's do all of these up here, right? And then if running task, okay. Now we have 7. Okay, now we have 7. Let's see if 7 is right. But still, let's not do this. Let's find the maximum time point. What can I find the max time? So max time equals 0. Doesn't matter. And a max time equals max time e. And the mean time. We should do min and max. Right? So max equals this, and the mean time equals minimum min time and start. And once we do this, we can just go min time to max time plus 1. All right. So we comment out this, do these two. They still pass. Let's see if that is correct. Okay, is that 7? It is 7. It is 7. All right, let's do another shot. Does not look promising. It looks slow. Now we have a wrong answer. Okay, wrong answer is a different situation. Wrong answer, that means the logic is not right. Well, really, we hit 1013 out of 1059. I think it's worth investigating this. Output 5, expected 6. So we're close. It should be 6. Okay, let's... All right, this is the last one. Okay, last one. We're gonna do this one more time. Last one. All right. We have 1 to 12. Okay. 1 to 12. 0, 1, 2. Number 2. 8 to 1. 8 to 11. Oh my god. 8 to 11 is contained within. 8 to 11. That's 3. And 10. Oh my goodness. Lord. 1 to 12. Okay. And 8 to 11. Okay. 8 to 11. And 10. Okay, I call this 10 to 16. And 10 to 20. Lordy. Lordy, lordy, lordy. And the answer should be 6. How do we do 6? Well, I say I do... My god, I don't even know which one's which. Jesus. I need to run this. I need to seriously run this. Oh. All right, so we have 0, 1, 2, 3. All of them, they start with position 10, and we can run 2 seconds. That is correct. Or 0, 1, 2, 3. at position 11, they can run 1 second. That is correct. So the first one, I say run 2 seconds. Once I run 2 seconds, wait, task 0, task 1, task 2, task 3 is gone. That is not right. Task 3 is not gone. Oh. You're not supposed to run. Wait, hold on. Task 3. Let's see. Task 3. 0, 1, 2, 0, 1, 2, 0, 1, 2, 3. Task 3 is 8 to 11. Last for 2 seconds. No, task 3 is gone. 8 to 11. Task 3 is gone. Right? So you'll run from 10 to 11. And once you're done, you will be 12. It will start at 12. Right? You will start at 12. You will start at 12 with 0, 1, 2. I think I have a 12 with only 1 second. That is true. And then, so that's 2 seconds. And then we have, I think that's the order now. Because when you run this 0 to 11, right? And then you say, I want to run 11 again. But 11 is already run. 11 has already been consumed. 11 has already been consumed. Right? Therefore, this 11 shall not be run because it's already been consumed. How do I... Because each second can only be consumed once. So we need a... God. What are you saying? Oh man. You know what? I'm gonna give up. This is not right. Too complicated. Too complicated. Alright, I'm gonna take a look at the hints and sort of tasks in ascending order of end time. Okay. Hey, number 2. Since there are only up to 2,000 time points, you can check them one by one. That is true. It is always beneficial to run a task as late as possible so that later tasks can run simultaneously. It is always beneficial to run the task as late as possible. What does that mean? To run the tasks as late as possible so that later tasks can run simultaneously. It is beneficial to run the task. Okay, that's a beneficial term different from what I thought. I was trying to line as many together, right, as possible, but this is saying it is always beneficial to run the task as late as possible so that later tasks can run simultaneously. I do not understand what this means, but we are going to see. We're going to sort them by the end time. Okay, let's go back to this example. We sort them by end time. Actually, how about you use this as example? Yeah, I think that probably is a good idea. The one that you failed on. We're going to sort by end time. So we have end time earliest is 8:11. Okay, so we have 8:11, 2. and 1, 12, 4, and 10, 16, 3, and last one, 10, 25. Okay, so we have 8 to 11, 1 to 12, 10 to 16, and 10 to 20. You always want to solve as late as possible, so you have more overlap. I mean, we do want to look for overlap, that's for sure. I mean, if you do it this way, then we can say, okay, so this is the late, right? And then we can draw a line here, right? As long as this is crossing, then we have overlap. If it doesn't cross, then we don't have overlap. So we can check on 11 and see how many have overlap. And I say, okay, all of them have overlap. So we can run 1 second, right? So this is task. So we can run 1 second. Okay, we run 1 second. We consume 11. Okay, we consume 11. After we consume 11, we'll move, this has to move to the left, right? So this is the maximum overlap, right? We use this, we can line up the maximum overlap. And once it's done, okay, we consume 11, and then we can consume 10, right? 11 and 10. Once we do that, this one's done. So these two are consumed. Now, we can check from here, right? So this has 2 left. This has 1 left. This has 3 left. Now we check from here, right? 12 is all within. Now we consume 12. So this has 1 left. This is done. This is 2 left, so this is done. Now we cannot consume 11 or 10 because we consumed already. Now we consume, so 10 is consumed. So now we're at 9 and nobody's overlapping. So I have to consume 9 because I want to finish this. So 9, this one's finished. Now for here, so this one's done. I need to consume 20. I need to consume 19. So 1, 2, 3, 4, 5, 6. What do you think? I think it's promising. I think it's promising. We line them up. We go from the first one. We move to the left. Okay? For every single time point, we check if it's within the range of every other time points, right? And if it is, we record this. Move 1 left. If it's not, it doesn't really matter. We have to do them anyway, right? We have to do them anyway. We have to do them anyway. So we do this, we check, 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 check. Whoever is in the range will get removed until the first one's done. Now we're looking at this. And then we'll get this done. And then we're looking at this. You know what? This might actually not be that difficult to program. I think I just needed to say tasks.sort key equals lambda tuple, and then do tuple 1, right? And then for rest equal to 0, okay? Then we say for, because we do one by one, each one, right? For I in range len tasks. Okay, so for this, then we check from here, right? And we need to move, and then we should say consumed equals set, right? Then we say t, okay, equals tasks I 1, while tasks I 2, okay, if t is not in consumed dot add this time point, oh man, while this and t is larger or equal to tasks I 0, right? Well, add the consumed, and then we go through everything to check if there's anything we can remove, right? Then we say for j in range from I plus 1 to len tasks. And each one I check if t is, if tasks j 0 smaller equal to t smaller equal to tasks j 1, you're in the range, right? Then that thing can also, because it's overlapping, right? Then we say tasks j 2 minus equal 1 if this and tasks j 2. All right, if that's the case, then we can minus equal 1, and then we just go through every single thing that's overlapping, and if it's not overlapping, we just don't do anything. And once we're done, right, once we're done, t minus equal 1, so we go back up, right? Then we check again, we go back up until we finish all this. And every single time we will consume. Oh, I don't even need the result. Consumed is the result, right? T minus equal 1. And once we're done, we go through the entire thing, we handle this. Then we go to the next one, right? And when we go to the next one, we do this. But if it's already been done, it just gets skipped and we go to the next one. So once we're done, we just return len consumed. It's not right. Okay. Okay. Don't worry. Don't worry. Be happy. Don't worry. Let's see. This is correct, right? But why are we not? That's fine. Let's check one by one. Let's check consumed, right? Let's check consumed. So we consumed 8 and 9. That is not right. What the hell, man? The starting t is 11. So the beginning is this, and I consume 4. What? Oh, I forgot to consume. Dude, you need to consume I 2 minus equal 1. You didn't consume yourself. Okay? You need to consume yourself as well. And then consume everybody. Can we run this, you know, if t not in consumed? Yeah, I can just go from this, right? We just add, and then we go from it as well, and it will just go through everything. This one pass, okay? This one pass. And then we check all the rest. Dude, I think this is right. This I think is correct. Me God. Me God. I think this is right. Holy crap. It might be right. Oh. Oh. Oh, the hint. Oh my, the hint. Holy crap. Is it slow? Yes. That's O(n) squared. But, oh. Well, that's actually more. Because you have go through everything. And here you go through everything. And here you have to go through everything. So it's more. So O(n) squared times the task, right? Yeah, it's more. It's oof. What we call it? What do we call it? I mean, task is definitely smaller. Actually, I don't even think I need to use this, but I just put this. It should be this, right? This. So oh. T, we call it T, O(n) squared T. But dude, this one works. Holy crap. Oh, well, the hint works. Marvelously. Alright, so sort the task. Sort the task is by yeah, actually I don't think this is necessary. Sort the task is by end time. Okay. We start from the task with the earliest end time to maximize parallel work. We want to draw a line from the first task's end time through all the other tasks. Any task that gets crossed by this line can be paralleled with the first task, right? Then we check the second to the end time of the first task and do exactly the same thing, right? We try to maximize parallelism for the first task until the first task is done. Then we start from the second task and then repeat the same procedure. Now, the one thing to note is that each second can only be consumed once. Thus, we use a set to keep track of all the seconds consumed. And the final solution is the length of the consumed set. O(n) squared times t, right? Where n is equal to len tasks, and t is the, I'll call it average length of each task. Is it slow? Yes, it's very slow, but we got it. This one requires a little bit more study, so we'll look into it. There are O(n) log n solution, so yeah, definitely have to check. Okay, that will be it for today. Oh Lord, you forgot O(n) log n. Yep, sorry. Yeah, we'll do the learning tomorrow. All right, I'll see you guys tomorrow.